Good afternoon, everyone. Yes, today we are having a session on facades. So, Mr. Gaurav Tiwari is here today with us, and he will guide us what is the facade and what are the benefits of the facade and why we should go for the facade. So, Mr. Gaurav Tiwari is a facade consultant, and he is having from LM Facade Consultancy, and he is having past 10 years of experience in facade field. So, I am welcome Mr. Gaurav Tiwari on behalf of KRC Metal Box team. So, Mr. Gaurav Tiwari, hello, Mr. Gaurav.
Yes, Durgesh ji. Yes, Durgesh
Yes,
ji.
yes. Please continue now. Thanks a lot.
Okay.
Yeah.
First of all, welcome all to this afternoon session. Hello. Am I audible?
Yeah, Gaurav. Yeah, Gaurav, you are audible. Yeah.
Okay. So I would like to thank KRC team for allowing me to be a speaker onto this session. So with that note, we start the entire discussion about facade. So as we talk about facades, let's see what are the current trends, what was the history, and what do we see as facade in next generation. And KRC, being one of the most prominent developers, has always been into that race of doing something extraordinary and giving it best to the tenants as well as the residents. So with that note, we start the presentation. So that's our company called LM Design. We are facade consultants. So this specifically presentation is not about any company or any brand, but we are just inculcating a part of knowledge to all the engineers out there for the KRC team. So introduction to facades in India. So many of us would be wondering that why facade? We were happy with the stone cladded buildings or say masonry walls. So the answer to your query as why facade is, but before that, what is facade? So what is facade? The basic definition can be as facade may be termed as an outer envelope of glass, cladding, stone, etc., which is not casted along with bricks and mortar, but then to forms the face of the building is called facade. So into a layman's language, facade is a form of a postman. It's a non-load bearing member. So it not only it doesn't allow the wind load to be acted upon itself. It just is the medium of transport of wind load to the main structure. So we can also call or name facade as a postman. But that is the first thing that a layman notices when he enters the building, or the last thing that he notices when he leaves the building. So because of facades, you get many iconic shapes for the building. So now comes the question, why facade? When I say why facade, these are the points that must be known to every designer, to every architect, to every guy working into construction field, so that he can answer up to his seniors, so that he can answer up to the next generation coming up into the construction industry. So it gives you corporate identity, unique shapes, complex designs, results in architectural wonder, pleasing material, see-through elevation, lively building elevations, and also better acoustical performance. So it's a genuine request to all the engineers, all the architects listening to me currently, that we have ventured into a generation wherein we have a very different and a varied kind of university called WhatsApp University. So my request to you guys is don't believe in those things until and unless you verify it. There are some series of photographs wherein facades are being blamed for the fire, facades are being blamed for the excessive heat generated. So it is all with the help of a knowledgeable consultant. You can get rid of these all queries. And of course, facade is not to be blamed through, because it gives you these many advantages over the conventional design, or say the normal design that we used to follow 20, 30 years back. So now whatever that facade used to give us, we are supposed to have the same functionality with the help of a small thickness of glass. Sometimes it is just 24 mm. So this 24 mm is 6 mm glass, 12 mm air spacer, and 6 mm glass. So the overall functionality that used to be achieved with the help of those stones, or say the mud walls of 1 meter, now we are supposed to get it in just 24 mm, or say an inch or so. So now there arises a specific question of need of design of facade. So the need of design of facade we started with, and there comes the slide wherein if you have a notepad with you, it's a genuine request. Please note these terminologies, because these are the things that we as engineers, as production, as site team, as procurement guys, as design chaps would be keeping on listening to them. So the need for design of facades is, number one is weather. When I say weather, weather itself has two parameters. Number one is air. Number two is water. When I say structural itself has two parameters. Number one is positive wind load, and number two is negative wind load. So I'll brief you about this with the help of this photograph. So when I say positive, so when we consider wind in action, we say any particle in fluid, wind is considered moving air, moving wind is considered as fluid. So moving any particle into this wind in this direction, moving towards the building, will hit this building and will not go back. It will try to regain its path of motion, this path of motion, this path of motion. So when it hits the elevation, there is a bulge created on the facade. So this bulge creates a concave effect on the elevation. So when you see the glasses going into concave, it's called a positive wind load. Where does the negative come from? Is it exerted from the building, inside of the building? Is it exerted by the tenants? Is it exerted by the HVAC? The answer is no. At any given point of time, this wind load hits this is positive, but this entire elevation, onto this entire elevation, 50% only is positive, whereas 25% of this corner, 25% of this corner consistently remains in negative wind load. So what is negative? Negative tries to lift and drag these panels, these corner panels. You see, we see that these corner panels are lift and drag mechanically. If you understand, it's a drag phenomena. Like if somebody is driving a bike on a rainy day or a normal day, and we have a truck passing by or a trailer passing by, we see the bike moving towards inside the trailer. Or say if you're standing onto a platform and a train passes by, like a Rajdhani passes by, you feel a drag towards that train. So that drag is called negative wind load. And believe me, remember this thing, negative is always higher than the positive wind load. So that covers the positive and negative structural part. Now into structural itself, there is a dead weight of the entire facade elements which is transferred to the ground with the help of proper designing. So everything and anything that we look at facade has a specific load path to it. So with the help of that load path, that entire load of wind load or structural load or dead load is transferred to RCC, and from that RCC to Mother Earth. Okay. Then we have seismic. Seismic is a phenomena which is much more taken into consideration while designing of facades, because
It's
at any
15:15.
given point of time, if at all there is a seismic moment, if at all there is an earthquake, there is a lateral moment. Very rarely we see the vertical movement into the Earth's crust. So during these lateral movements, when there is a lateral movement at the ground floor, the first floor, if the ground floor moves leftwards, the first floor moves rightwards. So that's the difference. So this drift, we call it interstory drift. So these drift create much more impact on the facade. It must not happen in such a manner that if at all you see an earthquake happening in one area and the entire glass panels are down. So the facade has to accommodate these seismic movements. So we design facades for seismic also. Also, acoustic plays a vital role. Many a times, if at all the developer is not convinced about usage of correct glass, so I'll come back to glass on this, but correct glass. If at all it's an IT complex, there has to be a DGU. If at all it's a school building, it has to be a laminated glass. So these are the things that are of much more concern. There comes, and then comes the final one, the safety parameter. Last but not the least, everybody, every engineer, every designer, every architect tries to look at safety as only one aspect, but it is only a facade designer who looks at it with the help of a different perspective, wherein we are not concerned only about the safety of people inside the building, inside the facade. We are concerned about the people moving in and around the periphery of the building. So this differentiates design of facades from the rest of the RCC and structural members. Then a basic differentiation between glazing and cladding. Many of you must be knowing this, but just a revision. So wherever we see glass used, wherever we see see-through environment, see-through elevation would be termed as glazing. And wherever we see a dead elevation, whether it be a duct area, whether it be a service area, whether it be a dead wall or a parking lot, so that elevation wherein you don't see or you don't envisage that the outside people must be having a clear view inside what's going on, it's called cladding. So cladding is again of basically four different types. We use metals, we use stones, we use bricks, we use composites for the cladding part. Now we come to the materials which are used in facades. So, of course, the presentation would be much more elaborative. But of course, if you have a notepad, it would be making easy to remember and sail through the presentation without getting dizzy about it. So materials used, we'll just touch base with the basic materials which are used and are of much more concern to us. Okay. So first and the foremost material that we are interested to know is glass. So if at all you are ready with the notepad, the three statements that you see on your screen, please memorize it, please note it down, please take a screenshot of it. So glass is, as a subject, is of ocean's depth. We are not getting into the ocean, but we are just trying to have the knowledge for facades, for our day-to-day activities, for the normal construction activities, what type of glasses are used, where it is being used, and how to be arranging the configuration of it. So the first statement goes, generally in facade, heat strengthened glasses to be used. When I say heat strengthened, I'll explain it. What are those? Whenever there is a drilled hole in glass means a drilled hole in glass, please only there use FT glass. What is FT glass? What is fully tempered glass? We'll understand in the due course of the presentation. Any overhead glazing and railings, wherever there is human interaction, that has to be of laminated glass. So what are these HS, FT and laminated? We'll understand in depth. We start with HS glass. So HS glass is a glass which is say 2 times, if you look at this statement mechanically 2 times strength of annealed glass. Annealed glass is the raw form of the glass, which is also called a kacha glass. The normal glass which has no strength to it. It can be broken with just a punch, or a normal impact onto it can shatter it. Now, heat strengthened is a glass which is obtained by heating the glass. Any process which has heating into it will result into a strength development into the material. So similar is the case with the glass. If we have one glass and we decide to make it heat strengthened, what we do is it is elevated to, it is again, the manufactured glass is put again back into furnace and it's been heated to 620 to 650 degrees Celsius and gradually allowed to cool. When I say gradually allowed to cool, it means that there are minimal distortions into the glass. At the same time, this becomes 2 times stronger than your annealed glass. So this glass is most appropriate to be used in facades. But the only drawback is since it has no strength pertaining to the holes made, wherein spider glazing is to be used, like the last point we say, cannot be used into point fix glazing. Cannot be used. Because for the drill hole, the previous one we said, for drill hole we need FT glass. So heat strengthened glass, some beautiful mechanical properties that we see. So properties are thermal shock resistance up to 130 degree, 2 times stronger than annealed glass, but the only issue is it breaks down in knife edges. So you can see here, these are the patterns into which it shatters. So if at all you, next time when you see a broken glass, go near it and see if the pattern is of knife edges, by default, either it is annealed or it is heat strengthened. Now comes the FT glass or tempered or toughened glass. So when I say this, here you see the mechanical strength of FT glass is 4 times the mechanical strength of annealed glass. So what happens is this entire process is called rapid cooling. So we heat the glass to 700 degrees Celsius and then rapid cooling. There is a forced convection. There is a cool air which is blown from both the sides, up and down of the glass. What happens is the surface compression is more. If you look at this, here we get a surface compression is 6,000 to 9,000 per square inch, whereas here we get 11,000 to 20,000 per square inch. But since it is quenching, this process is called quenching. So we have more distortion due to sudden cooling of glass. It is also called as FT glass. It is also called as safety glass. Now, many of us, or say 99% of us, use mobiles, and onto that mobile we have a consistent use of FT glass, third-party glass. We buy it and we allow it to get stuck to the screen. And believe me, we all are just fooled around by the guys. It is not glass, it is fiber. And if at all that thin glass is to be manufactured, probably the cost of manufacturing of that thin glass would be equivalent to that of a cell phone. So that's not FT glass. Now comes the problem part of nickel sulfide. One problem that consistently we see into this tempered glass is spontaneous breakage. You see that the glass is there one day and suddenly it breaks. It is also called a ghost effect. So this nickel sulfide is a particle which is inside the glass as an impurity, and whenever this glass is exposed to atmosphere during 3 to 5 weather cycles, this nickel sulfide, being a metal, tries to expand and shatters the glass. So when you say it shatters, it creates this pattern, and if at all it's a laminated glass, only then you can see this, or else you see this as a breakage pattern of FT glass. It is also called sugar glass. It is also called Bollywood glass. So when you see a Bollywood action hero jumping and shattering the glass, it is of course an FT glass broken from the corners. These glass are strongest at the center. Believe me, listen to me. These are strongest at the center, weakest at the corners. So when you hit the corners, when this glass has been hit at the corner, it shatters very beautifully, like sugar crystals. So when you have a Laminated glass, only then you see these two polygons or these two butterfly effect, and this is the part wherein that nickel sulfide would be causing the breakage because of its expansion. Now, to eliminate this nickel sulfide, this NIS, we have a process called heat soaking. So what we say into this heat soaking is the entire lot of glass this glass is allowed to again go into furnace. When this glass entirely goes into furnace, whichever glass has nickel sulfide shatters on its own. So it is again heated. So you can see tempering process increases the strength of glass to manifold, and because of the spontaneous breakage, when glass is heated, nickel sulfide is formed. But when this glass is again heated, inclusions are modified into form that grows and transform. Now, nickel sulfide can change the structures and volume during the heating process. So whatever happens into this heat soak into the furnace just uh, gets you the perfect glasses out of it. But of course, it's a costly affair. So where do we use this heat soak test? So heat soak glass are to be used when there is an overhead glazing. Wherever there is a glass fin system like this, you have to use a heat soak for this part, because this part is a structural member out there. Then comes laminated glass. So when I say laminated glass, we understood HS glass, and HS glass was much more, say, 2 times stronger. We understood heat strengthened FT glass, which was 4 times stronger. So now when we see laminated glass, we require a safety of more than 4 times of that of annealed glass. That's why what we did was we took two glasses together and we laminated it with the help of a resin between it, with the help of a glue. So it's a mechanical definition. Any two homogeneous materials stuck together with the help of a glue, with the help of a layer, with the help of a resin, it's called lamination. So that same phenomena we used with glass. So when we use this with glass, we get a laminated glass. When you see this, it's called the first light, the second light, of course, it's called glass. And then we have a PVB interlayer. This PVB is now being replaced by a company called Curare. We also know it as Sentry Glass Plus SGP. So PVB in nature was hydroscopic in nature. It used to love water. So if at all there is a laminated glass and it sees water during rains or during cleaning purpose, it absorbs water and it delaminates. So in that due course, what happens is the entire purpose of lamination of having more than 4 times strength is lost. So then came this company, did its R&D and came up with a product called SGP, which is hydrophobic in nature. It doesn't like water. So what happens is you can have exposed edges. Even if there is water, it doesn't react. And it forms a homogeneous material exactly like glass. It is harder to feel. So whenever next time you see a laminated glass, go to the lamination and try to feel that lamination. If at all it is soft in nature with the help of the tip of your nail. So if at all you can pierce it, you can just push it, it is PVB. And if at all you feel that it is a thin glass, so it's not glass, it is a lamination. So that is a laminated glass. Of course, these gives the best most output for acoustic property. Laminated glass are the only glasses which are used for bullet resistant, are also used for the VVIP cars.
It's 15:30.
Laminated glass have the usage into canopy. Laminated glass can be used for blast resistant, bullet resistant, and also for local understanding. We also use it for laminated glass for railings. So it's a must. As a designer, as a project head, as whatever responsible roles we are into, we need to have laminated glasses used for all the railing part, minimum. Then we have an IGU. IGU is also called DGU, which is also called double glass unit or insulated glass unit. Now, these two glasses are stuck together with the help of this glue, black color. So this is a seal, whereas this part of the trapezoid has a PIB, polyisobutyl, which is a non-curing gum. It it holds both the glasses together. So these are two glasses. Now, when IG is to be used and when there is a laminated glass to be used, there is much more confusion into civil engineering, say fraternity. There are many people who say double glass laga lenge. When I say double glass, he means this also. The engineer means this also is also a double glass for him because it's laminated. There are two glasses, but there has to be someone to clarify whether the usage, the term called double glass, is an IGU or a laminated glass. So that's why I say again I make a request that whenever next time when you talk about glass, it has not to be spoken as double glass. It has to be quoted as insulated glass unit and laminated glass. So laminated glass are to be used for only acoustic properties. Insulated glass are to be used for thermal properties only. So when I say thermal properties, just a thing for you to remember is a normal refrigerator that we look at every refrigerator of Pepsi company, Coca-Cola, or any cooling company that gives you those drinks, soft drinks. So they use this DGU, this insulated glass unit, to hold the temperature inside. So that is IGU. Whereas when you go to any five-star hotel just next to your airport and you look at the glass and you see vehicles passing by and you don't listen to the sound, that is a laminated glass. So that completes the glass, wherein we touched base about the various glass, where and how to be used. Now we come back to various materials used in facades. So we start with stone. Stone, of course, was a favorite of all. Then stone. When I say it can be say dry stone, it can be sandstone, it can be laminate. What do you call it? Sedimentary stone, granite. Then we have bricks, which we had used very vastly in the entire history. Glass, of course, we covered. ACP. Now, when I say ACP, many of us are like, "Pata hai." We know the subject. We know it. We have used it many projects. When I say ACP, it is again a matter of concern, wherein now with the breakage of fire in and around many cities in and around the world, many of us are concerned about usage of AC. Of course, the product is not faulty. It is the specification that was wrong. The guy who was writing down the specification must have taken the due course of attention. So, when I say ACP, these are two aluminum sheets together, stuck with the help of this core. Now, when I say this core is the element which catches fire. If at all, it is a non-FR material. So there are ACPs into market wherein it is non-FR and FR. You see ACP used in projects, you see ACP used in signboards, you see ACP used in Oppo and Vivo branding of mobile phones and others. So ACP has, without us being knowing, we see ACP everywhere into the market. So we need to know what type of ACP to be used. So when I say what type of ACP, believe me, next time whenever an ACP supplier enters into your premises for an order, ask him for at least a 30-minute or a 60-minute or a 90-minute fire rating. For a residential building using a fire rating, we always recommend to go at least minimum 90 to 120 minutes of fire rating of ACP. Because if I talk about Mumbai, we have the largest boom, the longest boom for the fire CFO, which is just 90 meters, whereas the buildings that we are building are above 150 meters. Like Lodha, if you talk about, the maximum towers are about 200. So if at all the ACP which is used over there, it is non-fire rated. So the fire catches up like spreads like this. So last week we had fire in Sharjah. If you look at the videos, those are more deadly videos, and the fire uh, spread so fast that because of the use of polyethylene, the fire being a petroleum product, it catches fire. When I say fire rated, the core has to be containing magnesium oxide. So when there is magnesium, magnesium comes out as a normal material. Oxygen oxidizes with hydrogen and forms water. It doesn't allow. First of all, it will not catch fire, and second is, even if it catches fire, the magnesium precipitates and the H2O is formed, and it doesn't allow to propagate. So into this ACP, we have two basic systems. So what first system we have is a closed joint system. And also there is a myth into the entire fraternity that uh, wherever there is a leakage, fill that groove with the sealant. Believe me, putting sealant is nowhere the solution for the leakage, because wherever there is a sealant, wherever however good we are into applying sealant, after curing there are air gaps, hairline gaps created, which act as cavity, and during the potential pressure drop, the water gets sucked into from those hairline cavities. So we as designers suggest not to go with closed joint system. Closed joint system will look like this. So when you see an ACP, this is inside, this is outside. This blue part is the ACP, aluminum closed joint. So this would be ACP. Of course, this system is very beautifully designed by us. We don't say, we see directly people sticking on ACP on a double-sided tape and then filling the gaps with the help of this baker rod and a sealant. Believe me, this sealant gives you stain marks. You can see stain found on ACP facade, and the facade looks really shabby. And if we are designers, loss for this system. This is, of course, very much favorite of all the designers, but we as designers say no to this, because a dirty facade doesn't fetch anybody a good value for money. So what is the solution of it? Solution is ACP into an open joint. So instead of that sealant, we go with the rainscreen principle. When I say rainscreen principle, we allow the water to get inside behind the ACP, and we have drainage slots which allow the water to again come out of the facade. So the entire cavity is called a ventilated cavity or a rainscreen principle. No pressure build up between the ACP and the wall. No deflection of panel under thermal expansion. No stains on the ACP at all. So the detail that you see looks like this. So it just slightly comes outside the building periphery. So because we are using this as an additional member, this frame, the gray color, you again have an ACP and you don't see a sealant. And this gap, a standard gap maintained, which we ask for, is 10 to 15 mm, depending upon the architect's choice. So this is the perfect system we are talking of. Then, of course, for the podium area, we have much more doubt what to use, what not to use. So I have compiled some beautiful products for you. We'll just go through the photographs so that we don't feel that we look at new materials and we don't feel that, oh, it's a boring session. So the first option comes as a GRC or GFRC. So GFRC are pattern onto the facade, which are created with the help of molds. So into those molds, we have some parts of clay, some parts of drying mixtures, and also some parts of glass into it. So it looks very beautiful, and when litted upon, this these minute crystals of glass glow in the dark, and it gives a very beautiful aesthetic appeal. Of course, this project of yours is into my presentation as a usage of GFRC Jali. It's of course Bavaria, very close to our heart. Very much proudly going and seeing this project every now and then whenever I'm there. Then we have GFRC Jali options. TCS Kochi, I was a designer for this, and we used it very beautifully. Aluminum expanded Jali also is a new material into the town, and we also have various colors to it. So since aluminum is the base material, you can go with the normal anodizing colors and also PVDF, which are almost like 1,000 in numbers. We have aluminum sheet with perforation. So into this perforation, you can drill holes into glass. You can have stars. You can have leaves. And you can have logos perforated. Stainless steel mesh, of course, an expensive affair, but once installed, it's a zero maintenance product. So it doesn't require cleaning, it doesn't require anything. You just have to spray water and you get rid of the entire dust particles onto it. Aluminum louvers, of course, now since the architecture in India has also started evolving, we come across louvers into many projects wherein the client asks for automation into it. So these are fixed louvers, and the first photograph, this one, are automated louvers. Aluminum vertical features, we also call it louvers. These are photographs from uh, the internet, wherein this shows a dynamic louvers, wherein these are the fixed ones. These are again glass used as vertical features. So falls under the category of louvers only. But this also helps as self-shading device. Chera boards, of course, is a known product. Zinc cladding. Now, zinc as a product is a beautiful material, and the beauty of it is it doesn't fade away with time. So they also have a ZCP, zinc composite panel, but zinc as a material, if you put it onto your elevation, it gives you much more aesthetic appeal. The richness, or say the glow for the entire building, is superb. Korean cladding, of course, as designers, I have my own hesitations to put this onto the external, and of course, onto the Worli, the tallest tower that we see of Shriram Mills, the Palais Royal, or the Palace Royal, many people say. The intent of it is to use with go with Korean cladding. Don't know when it will be finishing off, but whenever it finishes off, Korean would be for the first time used as an external material in India. These photographs all are from the internet and are of various projects of friends and colleagues doing these projects. So it looks beautiful. It remains white. I don't know how does this react to dust and the climate that we are in. Then we have a product called fiber reinforced plastic. Of course, this product is not sold in India because of the NBC. NBC says no plastic materials to be used onto the elevations, which is combustible in nature. Wood veneer cladding is known to many of us. We use veneer cladding onto the exterior. Natural clay tile, also known as terracotta. Many of your projects of KRC have it. So these are extruded like aluminum. The tiles are extruded in nature.
It's 15:45.
Then we have honeycomb panels. Now these are some of the favorite of mine, wherein a thin slit of a granite is been stuck to a honeycomb like this, and the weight exerted by granite to the civil is reduced by 1/4 of it. So if at all I say 1 square meter of granite is weighing 80 kgs, 30 thick. By using this honeycomb, you can be using just utilizing only 20 kgs of the entire system, and yet the look and feel would be looking as granite only. Then we have vitrified porcelain slabs, we have vitrified tiles, we have porcelain tiles. Now this is a new material which was also given to explain to KRC team for various projects, for the cladding part, for the spandrel area insulation. So instead of ACP, we can be using porcelain tiles which have just a thickness of 3 and have minimum they exert minimum load onto the structure used for facade. The best part about these porcelain tiles is that these tiles have anti-shatter mechanism of film or a mesh behind those. So even if it shatters in worst most scenario, it doesn't fall off that easily. So we have one project at Thane, which we did with a similar product called Lamelem for Deepak Garudia Saab. Dosti Imperial is the project's name. You can, whenever you are free, you can, after lockdown, of course, you can go and have a look at it. It looks really beautiful. Ceramic tiles are known to all. Fiber cement boards are also known. But these are, I've clubbed these all materials together just to have a knowledge about that. Yes, these are the materials. Of course, we know it, but consolidatedly, I'm presenting it to you. So HPL, again, HPL as a designer, I have my own limitations and hindrances and questions asked about it. But yes, as a product, it's been widely and variedly used into overall world. I, as a mechanical engineer, I found this material to be of much more concern because the base of the material is paper. The laminate is created 6 by pressing 60 sheets of paper, gluing them together and pressing them and rolling it out in the form of sheet. So of course the seller, the manufacturer says it comes with a fire rated property because of the glue. It comes with no weathering effect onto it. But somewhere I have my own limitations onto using this material for the external part. But yes, these have been widely used across the globe. Then we start with the basic system as curtain wall, aluminum system. Now, when I say aluminum system, there are many doubts of people. What is a curtain wall? Why is it being used? And into this session, we are not covering windows and railings. We are only covering systems of facades, wherein for commercial building, because we are talking for talking to KRC team. Okay, so what is a curtain wall? So curtain wall is defined as a thin, usually aluminum framed wall containing infill of glass, and they would be from floor to floor. So some basics that we need to revive. Horizontal members, you all must be knowing also this. Horizontal members are called transom. We'll be addressing them as transom. The vertical ones would be called as mullions. These are casting channels. So at the time of installation, at the time of casting itself, these casting channels are taken near to the edge of the slab and marking edge minimum distance around 100 and 150. These are being installed and they are ready to receive the facade. If you look at this, the bracket is used. The bracket can be installed by just inserting this anchor into the casting channel. And then, of course, some spider glazing and spigots. So we start with, these are the things that we are going to cover. Major curtain wall types. We started with conventional. The name itself suggests conventional, Purana, old. Then we came up with stick glazing. Stick glazing was into, this is the graduation basically. The entire facade fraternity started from curtain wall, went to stick glazing, went to semi-unitized, now unitized, and If at all the KRC team allows me to present into the next session, we would be talking of futuristic facade. How will the future look like? So first of all, we are covering till now, say 2020. What will the facade look like? So we start with conventional curtain wall. So what is a conventional curtain wall? Normally, this is a detail which is said was used 20 years ago, 15 years ago. So what happens is you see this as a horizontal member, transom. So this being mechanically, the glass being mechanically held, the glass is being held with the help of this metal to glass contact we are avoiding by the usage of this gaskets. And the glass is fixed to this frame with the help of this pressure plate. And then we have cover cap. So the architects don't like to see nuts and bolts and screws, of course. So we see this screw is being hidden. Now, with the usage of this, the diagram, of course, we all are engineers. We love to see the exploded view. How will it look? How will it look? So that's the vertical mullion. That's the horizontal transom. Transom get screwed to the main mullion with the help of these fixtures. Then we have this gasket. We have this gasket. This is the pressure plate with the gasket holds the glass, and then there is a cover cap. Now this cover cap can be of any shape, can be square, can be elongated rectangle, can be of aerofoil, can be of full nose. Now, as designers, as engineers, we are happy about designing this system. Okay, we can install glass perfectly fine. Now what happens is it is labor dependent, and you require is scaffolding, the H frame, or the local slang we call it paranchi. So paranchi is a need of the time here. We have to use paranchi for 100% installation, and the installation happens from outside periphery. Now imagine a project like Kohinoor Square or a project like Ruby Tower, wherein there is just road on the outside of the project. So can you erect a paranchi there? The answer is no. And also, since it is labor dependent, and since these gaskets were initially used as rubber gasket, into the weathering of say heat and cold, they used to shrink. So when they used to shrink, they used to ask for water to get inside the system and have a possible leakage. Also, since it is labor intensive, laborers are supposed to carry smaller glasses, cannot be utilizing more or say bigger glass panels. And from an architect's perspective, believe me, after 10 to 12 years into the industry, we have developed a sense of vision like an architect. So whenever I see a curtain wall system project, I see a dimple mark onto the glass. So that dimple mark is because of the pressure, localized pressure, which this screw exerts on the glass wherever this has been fixed. So these are the drawbacks because of which curtain wall asked for a next level of R&D. So then we came up with a beautiful system using sealant. So when I say a beautiful system using sealant, we decided to cover the two parts apart from that rectangle glass, either vertical or horizontal, to be using two-sided structurally glazed sealant. So here if you see, these parts are with sealant. So the vertical ones are with sealant and horizontal one are with a pressure plate cover cap. So wherever you see horizontal band, it's a two-sided SSG, two-sided structurally glazed curtain wall. So still the difference is you need a scaffolding. Still there are dimple marks onto the glass. Still the architect perspective is not serve the purpose. So then we as designers came up with the solution of utilizing structural sealant, this sealant on the entire four sides. So when I say usage of this into the entire four sides, we said Okay, let's go with four-sided structurally glazed. So glass is held by structural sealants on all four sides, no visible aluminum membrane member from the outside. So the usage of four-sided created an architect-friendly environment wherein he wanted a glass-to-glass joint. He didn't want it to see an aluminum visible from outside, either horizontal or vertical. Less distortion since there is no pressure plate and screw mechanism. Weather sealant with the help of EPDM gaskets. Initially, it was sealant. We have started using EPDM gaskets. So this is the thing wherein initially we started using a weather sealant to fill the gap, and now this entirely is glass to glass joint. You can see this glass to glass joint, and this is the weather seal. So the intention of the architect was 100% met, and he was very much happy towards that. Yes, this is possible. Now, since we are capable of four-sided structurally glazed, we decided let's utilize a factory setup. So we decided to go with a semi-unitized curtain wall. Now, when I say semi, it means half. Unitized means into a plug and play mechanism. So if you look at it from the mobile perspective, initially we used to buy Nokia phones, say 15 years ago, 20 years ago. So Nokia phones used to come with a disk, a CD, a data cable which would be separate, a charger which would be separate, a hands-free which would be separate. Correct. Now we go and buy a smaller case, we spend of course more, but into that one data cable and one charger adapter serves many purposes, right? So that's called plug and play. So semi-unitized. Unitized is just plug and play. So how does that happen is the entire thing happens into two parts. So this figure gives you much more better understanding. So this gray part is erected at site, held together with brackets and waiting for this yellow part, which is with glass, structurally glazed glass, coming from the factory and getting installed onto this mainframe. So we also called this as mainframe and subframe. We also called this as mainframe and sash frame. So looking at this, what happens is still we can be using bigger glasses, but not jumbo glasses. This cannot be covering the entire floor to floor. And also we cannot get rid of that paranchi. So if at all you need to create a project like Koinur Square or Ruby Tower or KRC Hyderabad 12D, we cannot be going with a semi-unitized system, right? So then we decided to come up with a beautiful system called unitized. So unitized, I have a video of it. We can be sharing it once we are done with the presentation. So unitized, what we have is the complete system is plug and play, and the entire thing is called positive negative locking. We also call it male female junction. So the water tightness what we get into unitized is phenomenal. There is no leakage. Then what we get into unitized is there are no loose components at sides. There the installation expedites by almost 40%, and water tightness is perfect. So if you look at this picture, you get to see this being the female part, this being the male part, the positive part or the negative, positive and negative locking. So the entire frame to frame, floor to floor is being done like this. I can also help you understand this better. And the cavity, the spandrel,
It's 16 hours.
covers the fire stop as well as the smoke seal as well as the acoustic barrier. So if you look at this, so it starts with A. This is the A part. B, C, D, E, F, G, and H. So these all four panels come together and behave as one unit. So just I have a quick animation to explain to an engineer. Excavation, slab and column. So bracket, panel, bracket, panel, brackets, panel. So the installation becomes very fast. And from that's the type of bracket. Of course, we use two anchors and two holes for the having it. Fixation happens into this manner, and of course, frame fixing is you see this part ready to receive the next panel. So this part would be considered as positive, and the next part would be negative. So you can go with the vertical height of almost like 90 story and nothing happens. And then comes the point fixed glazing. So we are almost nearing the completion of the presentation, wherein point fixed glazing is again a very prominently known phenomena, but not many people know. We have seen it uh, at many places, but not many people know that these can be done into various patterns and fixity details, depending upon the uh, conviction of it, how the architect has conceived it. So the first thing we start with is tension rod. So when I say tension rod, it has a zigzag pattern, and this you can see at the Mumbai International Airport. So at any given point of time, the rod remains in tension. So whether it be positive wind load or negative wind load, the rod consistently remain in tension, the horizontal rod. So we call it tension rod system. Then we have a glass fin system, for which we said we need to install is heat soaked glass, laminated heat soaked glass. What you see over here is a splice joint. Then we have is a truss based system. So we also have a glass loop wherein there are no glasses, there are no drill hole into the glass. So that is again a beautiful phenomenon. Just quick recap of what we did and understood past 1 hour into the system. So we started with conventional, then we had stick glazing, two-sided, four-sided, all their drawbacks and positives. Then we came up with semi-unitized, then we had unitized, then we had frameless system. So you can go through it for a, I keep this slide for 30 seconds. So just to make people more knowing about what are the systems. So let's move further. So now comes to the testing part. Many of us being engineers not know that how is the facade testing happening. What is testing? So when we go for even construction at site, we always go for cube test. We always go for lighting test. We always go for anything what we use for a project is subjected to test apart from facades. Because in India, there is nobody who has understood the basic methodology apart from the consultants that how to execute a facade. So when we see international videos, when we try to get the same elevations, glass to glass joints, bigger glass panels, they have already tested it, and their test is subjected to worst wind loads, worst seismic activities, worst situations. When you look at these, when we try to get inspired from those projects, we must also try to acquire the methodology or the design or the QA/QC process that those guys also follow. So into that due course, what we neglect under the bracket, under the banner of value engineering is facade testing. Of course, it's an expensive affair, but onto the overall project cost, if you look at, it is not even 1% of the overall project, not 0.1%, forget 1%. So what is facade testing? So facade testing, of course, since Durgesh and Pankaj have been instrumental in arranging this seminar, would like to emphasize more on this because we as KRC are developing more into commercial spaces. We must be knowing what is facade testing. So we start facade testing as importance and validation of design. So how does it happen? So design validation across industries happen. ऑटोमोबाइल में होता है, फार्मास्यूटिकल में होता है, सॉफ्टवेयर में भी होता है, लेकिन फॉर facades many people just skip it. So by testing, what we test is air tightness, water tightness, structural stability, impact safety, and fire safety. So what happens is, what are the expectations from the facade? Are, of course, pleasing aesthetics, adequate sunlight, thermal comfort, freedom from external sound, which comes under acoustic. Energy conservation. Not many of us know that even energy efficiency is being considered from facade. And believe me, if I talk about futuristic facade, not many people know that there has been already an innovation that a solar panel can be generating electricity even by using those glasses onto facade, and the efficiency is 72.96. And now I have two suppliers in India who can do this. So energy conservation also comes into picture. Moisture protection, safety, health and indoor quality maintenance, durability, maintainability, and of course repairability. So why to be doing performance test is an architect vision is only till the design stage. Concept, design, specification, structural calculation, shop drawing. How do you verify whether this design, which is supposed to be going for 3 kPa or 4 kPa or 5 kPa, is perfectly meeting those standards? How will the verification or the validation occur? Is only with the help of performance test. So how does it need? How does it happen? So on paper, to validate these by actual testing, we do this. So what are the testing? Air leakage. Now these are the codes. You can note it down. Air leakage, static water penetration, dynamic water penetration, structural, seismic, on-site water, performance test, railing test, glass impact, fire test, acoustic, and thermal test. So what happens is AMA standards says that for a performance test, there has to be 3 grids and 2 floor height of entire mock-up. So it is not like testing only one piece of glass. It is not testing only one frame of aluminum. It is not about testing only sealant. It is not about testing an anchor pull-out test. It is a test for the entire assembly. So that is performance test. If you look at this, these are the images that you see, actual photograph. So if you look at these images, that's the Kohinoor square cut test, which we carried out at a lab at Murwad for facade testing. Even corners can be tested. And also for on-site test, as per AMA 501.2, we can be carrying out these. So looking at all these possibilities, even the team which is involved into ITSC sets, needs to understand this part very authentically, that there has to be a test for BMU restraint pin. Now, where does your BMU restraint pin comes from? BMU restraint pin is a mechanism wherein the gondola, or say the swinging stage, comes down from the top of your building to clean the facade. So when something comes for cleaning and it is hung by ropes, it will try to swing. It will try to oscillate. So it's a basic phenomena of oscillation. So if at all it oscillates, it has 90% tendency to break the glass panels. So in order to reduce that glass breakage, or say prevent that glass breakage, these are the pins that come out. Hello. Yeah, these are the pins that come out of your facade, and your swinging stage can be just anchored to it. So these play a very vital role for understanding of stabilizing your gondola for the cleaning purpose. And of course, when you have louvers, there is a specific test as per ASTM, wherein you design and envisage a guy standing onto the louver with the help of a bucket of cleaning water to clean the surface. So that is again a louver load test. So that completes the training session. Of course, we as consultants have been doing forensic analysis. So we did one for a very beautiful campus that SP has, SP Shapurji Palanji at Fursungi, Pune. We did the entire audit of this entire campus, almost 18 lakh square feet for the facades, and the results were really amazing, and SP team was appreciative about it. And we also did forensic analysis of glass breakage for this project at Aurangabad. Now, we also have a channel onto YouTube for any doubts or queries. You can be going to the YouTube channel and hitting the subscribe button, wherein I've explained every concept of facade very detailedly onto the channel. And of course, that's the contact details of ours, wherein we brand the channel as Global Techniques of Architecture. The questions, if at all not solved into these session, can be asked on the WhatsApp on this number and can be mailed across the same mail ID. Durgesh, I am open to receive questions.
Hello, everyone. Yeah, very nice and very informative and very learning good session from Mr. Gaurav Tiwari. So, if anybody is having any questions, please ask. Hello. Hello, Gauravji. As a developer perspective, we are having one question that what are the cost savings we can achieve in building using the facades rather going to the traditional buildings?
Of course, the question is really very interesting. I regret of not able to show you with the help of a sketch, but since all our engineers, we can be imagining the answer. Imagine a conventional building, or say a normal building wherein there is no facade, a floor plate square in nature. Okay, so if at all you look at the perimeter of it, the FSI, since the question is from the developer's perspective, the FSI used, or say that the carpet area used for construction of a normal building, and look at that thickness of the wall. We are talking of the thickness of wall, the end wall, whether it be ACC block, whether it be a brickwork or RCC. So I presume minimum 200 का thickness होता है, and that thickness revolves around the entire perimeter. Durgesh, you are with me?
Yes, yes, yes.
Yeah. So on to that perimeter, 200 mm vertically and 200 mm का width का पूरा band चलता है, and that is a loss of sales from the sales perspective. Now, by using that, if at all I use facade, that 200 can be just accommodated into 24 or say at the most 50. So that 150 mm ka saving multiplied by your perimeter at one floor.
Okay.
Hello?
Yes, yes.
Yeah, multiplied by your perimeter, multiplied by your square feet of one floor, multiplied by the entire number of floors comes to the cost of the overall facade. So your facade overall is for free.
Okay.
I've done the similar exercise for a beautiful tower called ICC, Bombay Dyeing का.
Yeah.
So वहाँ पे the entire cost of facade was easily recoverable. I had just considered the sale price of 28,000 at that time, 2012.
Okay.
So 2012 का 28,000 का sale price multiplied by 150 into the perimeter for 60 floors was 72 crore.
Great.
और उनका दोनों बिल्डिंग का जो one was 30, other was 70. So it was going to 70, whereas my with the help of a smart design into facade, we could achieve was 72 CR का saving.
Great, great.
2 CR again saving हो रहा था. So it is all. That's why I said it is all about the understanding of facade of glass and also aluminum system. If you don't have a knowledgeable consultant to present you this, of course बहुत ज़्यादा issues हो जाते हैं इसमें.
Great, great, Gaurav. Anyone?
Yeah.
Anybody having any questions?
Gaurav Tiwari, can you hear me? अच्छा. Hello.
Yeah,
noise
Jatish.
ज़्यादा है.
हाँ नहीं, कोई पूछना चाहता है पूछ लीजिए.
हाँ बोलिए.
हेलो.
Yeah.
हेलो, सचिन गौकर बोल रहा हूँ.
हाँ बोलिए.
हाँ सचिन जी.
मुझे एक पूछना था. आपने जो अभी बोला कि वॉल्स की मतलब जगह पे वो जो जगह है वो बिल्टअप है, मतलब सेल के लिए फायदा होता है, बराबर?
करेक्ट.
हाँ, पर अगर आप देखें तो हम लोग जो बेचते हैं वो बिल्टअप एरिया ही रहता है. अगर आप वहां पे वॉल बांधो या वॉल वहां पे मत बांधो, बिल्टअप एरिया वही रहता है.
नहीं, आप समझे नहीं. अब जब आप अभी जो नया DCR देखेंगे, so the saleable area is considered to the glass film, glass का surface तक के लिए.
आउटर सरफेस.
आउटर नहीं, इनसाइड सरफेस.
इनसाइड सरफेस, राइट.
हाँ, तो आपको वो जो 200 या 150 का जो मैं बैंड बोल रहा हूँ ना, वो पूरा यूजेबल एरिया में आ जाता है, बिल्टअप एरिया में नहीं आएगा.
एक्चुअली सर,
बिल्टअप भी कारपेट हो जाएगा.
Yes, but according to new RERA rules, now carpet area is calculated including wall. I think so.
पता नहीं, मेरे को तो काफी अच्छा इसने बंदे ने ये दिया था, and the entire sales team was like gaga about the solution that we had presented.
Okay.
So
Okay,
let's
fine.
see. मतलब that is again from the sales perspective. भाई अपन तो डिजाइनर हैं, अपने को उतना ज्यादा समझता नहीं.
Yes,
जितना उन्होंने
right.
बताया उतना करके दे दिया था उनको.
Yes. Thank you, गौरव जी. प्रेजेंटेशन बहुत अच्छा था.
Thank you.
गौरव जी, मेरा क्वेरी ये था.
हाँ.
Means for the cost saving, the more the similar the what do you say, DGU panels that you design, the more the saving. If there is an different size of a DGU or the unitized panel, the cost will increase, right? Because of the setup at the factory. That is what is one reason, right?
No. कभी भी डिजाइन को लेके कॉस्ट मतलब change of unitized will never escalate the cost.
Okay. Means if my unitized panel along the periphery are of different sizes, that will obviously cost me more than if I consider similar widths of panels. Correct, or is that wrong? If I'm correct,
it is not correct, Sachin.
Okay.
Ninad. क्योंकि कैसा है, it is more once I say unitized system, मुझे लगाना है as a developer, as a designer, if I am your consultant, you and me are in agreement कि हमको unitized लगाना है. We catch hold of a contractor who has a setup for unitized, whether it be glass wall, whether it be innovators, whether it be any contractor. अब उस contractor के लिए तो unitized है ना. एक पैनल जो उसने बनाना है वो तो पैनल बनाना है, तो उसका जो आउटपुट है, मतलब इनपुट टू आउटपुट रेशियो will remain consistent, ना.
No.
What will change? What will change is only what will change is only the glass size.
Glass size, okay.
So glass size के glass optimization पे फर्क पड़ेगा.
Should go for sentry glass, okay, and heat strengthened, right? Because it is exposed.
Correct.
So the nickel sulfide, this thing will not be there, and sentry will not expand, and the laminate will not go.
नहीं, जब सेंट्री यूज करेंगे ना, तो सेंट्री के दोनों ग्लासेस हैव टू बी एचएस ग्लास.
अच्छा, heat strengthened.
Heat strengthened glass, yes.
अच्छा, heat strengthened. तो heat strengthening से पहले heat soak करते हैं, कैसा है?
नहीं, heat strengthening is a normal glass. Heat soaking is a process of reducing nickel sulfide out.
Nickel sulfide. तो मोस्टली वो करना चाहिए ना, बिकॉज इन केस
आपको मैं नहीं मैं आपको बोल रहा हूँ आप हीट सोकिंग तक जाओ ही नहीं. मैं आपको बोल रहा हूँ हीट स्ट्रेंथन में ही थोड़ा सा थिकनेस बढ़ा लो और लैमिनेट कर दो ग्लास को.
अच्छा, अगर टूटेगा तो नीचे नहीं गिरेगा.
हाँ,
इन केस निकल सल्फाइड से टूटेगा तो भी नीचे नहीं गिरेगा.
नहीं गिरेगा, करेक्ट.
Acha. My third question is, as you said, even for 90-meter facade, unitized glazing, if you are going, right? So beyond that, you require a break, or you can go further without considering the deflection and the expansion and all that. 90-meter is the limit?
No, didn't get your question.
जैसे आप unitized curtain glass लगा रहे, means male female, you are keeping on adding your this thing curtain. So what is the limit? Means because the building will definitely deflect, and you said my the unitized curtain wall, if designed properly, will have no leakage, nothing at all, but there will be a deflection of building beyond certain height.
Correct.
So what is the height till which we may have to have a break of the unitized curtain system?
नहीं, ऐसा ये मतलब I'll just reframe your question.
Okay.
इसमें क्या होगा, ये जो पूरा unitized system है, it is itself मतलब when I say break, वो already unit में ही जा रहा है, एक unit में है.
Correct.
तो उसमें ब्रेक का तो सवाल नहीं आता. दूसरा, when I say 90 meters, it is not a limit. It is 90 floors. मैंने बताया था कि 90 floors तक हम लोग ने किया हुआ है.
अच्छा, 90 floors. Okay.
अभी the project which was very close to our heart was Kohinoor Square. Kohinoor Square is 52 storied, 205 meters tall.
Okay.